What's up, guys? It's Hussien Jabai of Jabai Performance here with some firefighter research. Today we're going to explore some data that I collected from 3 firefighter subjects on movement with and without gear. Now, exploring them with gear, just a brief overview. I actually had them just throw on their bunker coat, so having their top, bottom, and boots. I did not have them throw on their air tank just for the restrictions of actually completing this battery of tests, and so I just had their coat on. Looking at each test individually, just to explain, in case you're not familiar with the thoracic spine rotation, active lying leg raise, and shoulder reach. Thoracic spine rotation is where an individual assumes the quadruped position. I had them place their hand either on their ear or behind their head, and they rotated up or externally rotated, and then I tracked using an app on my phone that degree of rotation. So I had them do both the right side and then the left side. And then the active lying leg raise, I had them lie completely flat on the ground, and I used a dowel that was already pre-measured using the FMS testing kit. I laid it right beside them, starting at the bottom of their foot, so it was in line or parallel with the individual lying on the ground. Then I used another dowel as they lifted one leg to trace where their ankle bone moves, and then as they're raising their leg up, the dowel would move forward and measure how far upward on their body or how far upward they're actually able to raise that leg. And then the last one's going to be the shoulder reach, where they do both sides. They reach up and then down and try to slide their hands together and see how far they can actually reach downward and upward with each hand, and then alternate and do the same thing. So exploring our subjects, just a brief overview. I kind of want to show the highest deficits on this data, and then just by looking at the chart you can show them individually, or as I publish and produce more content I can actually dive into each individual a little bit more in depth. But just showing a highlight on that thoracic spine rotation, I did see a huge drop off from one individual of 13 degrees, actually of 2 different subjects of 13 degrees. So that thoracic spine rotation, so this can actually hinder any throwing movements, any pushing movements, any kind of rotational you're having to move, having to twist. This can hinder their movement. So you're actually losing 13 degrees of thoracic rotation just by putting on gear. This has nothing to do with fatigue. This has nothing to do with muscle strains or anything, or inflammation or whatever it might be. This just has to do with throwing on gear. So we're already losing movement. We're already losing range of motion just by the equipment we wear. Next is the active lying leg raise. We're losing 18 centimeters of range of motion. So we're losing hamstring flexibility. We're losing hamstring or hip flexion range of motion just by throwing on our gear. So this can definitely hinder us as we're moving, as we're performing, as we're actually battling fires, as we're rescuing individuals. Just by throwing on our gear, we're losing this range of motion. And then shoulder reach, the highest was 13 centimeters. So we're losing 13 centimeters range of motion in our shoulders just by the equipment we put on. So then we have to ask ourselves, okay, everyone in every test lost or was in a deficit of range of motion from what they started with without gear. So then we have to start evaluating, okay, the gear saves our life but also hinders our movement. Is there a way to, one, to improve our movement, to improve our function before even putting on gear? That way that deficit, because obviously it's going to happen regardless. So how can we improve our movement, improve our function, improve our range of motion, improve our degree of freedom prior to putting on gear? That way when we actually put on gear, yes, we're going to see that deficit, but it's not going to be in that dangerous percentage or that dangerous range of motion to where we can still move, we can still perform, we can still rescue. And then 2, how can the industry as a whole conduct or create equipment that's going to not create such a deficit in our range of motion, but still prevent the heat, the fire, and everything from affecting our body?